Okay, so this is a second set of questions from the alkenes topic. They are all past paper multiple choice questions from old AQA A-level chemistry papers. Going to recommend you pause on the question, you try to answer it, and then you review. And that's going to let you know how confident you can be about this topic, or whether you maybe need to go back and revisit it. So let's start off with question 1. And this is a relatively straightforward question, but there's a lot of different considerations to make. We're looking at ethene in a number of contexts. Let's try and break this down a little bit. So, CC bond is twice as strong as the CC single bond in ethane. No, they are stronger, and you've done work on bond energies in the energetics topics. So you will be aware that it isn't double the value, even though it is stronger. It reacts with HBr in a nucleophilic addition reaction. Now, whenever we are thinking about that double bond and the double bond being susceptible to attack, it's not a nucleophile that's going to attack that, it's an electrophile. No geometric isomers because there is free rotation around the carbon-carbon double bond. Now, it's very easy to read through that, skip over words and miss it. There is no free rotation around the double bond. And that means it doesn't have geometric isomers, because I have got two of the same thing on each carbon. But this is not the reason for that. So that leaves us with what you could possibly have jumped straight to as the right answer. It burns in excess oxygen and it produces carbon dioxide and water when it does so, because excess oxygen implies complete combustion. Next question. So although it looks slightly different, this is essentially the HBr electrophilic addition mechanism with but1ene. So let's actually look at the mechanism piece by piece. My DBr there, my D being the heavy hydrogen, deuterium, and my electron-rich double bond, I'm going to have an arrow from there going to the delta positive D. Now that means the DBr bond can no longer exist, so the electrons in that bond move to the Br and they make a Br minus. But actually we've got to consider here the fact that the carbocation could be formed on either of these carbons. Equally likely to happen. Now, the left-hand side is a secondary carbocation. The right-hand side is a primary carbocation. And secondary carbocations are more stable, so products formed via that secondary carbocation intermediate are going to be the major product. So I end up with this. And the correct answer is C. Next question. Which of the following molecules would form a polymer containing this repeating unit? Let's keep this as simple as we can. Previously, there was a double bond between the two C's there, and the bonds that are then bursting beyond the brackets over there now to the next monomer didn't exist. So I've now drawn my polymer. Now from there, I can draw that in a slightly different way, a more familiar way, but that takes me, longest carbon chain, 3, it's methyl propene. So the correct answer is D. Next question. Huge amount to think about here. So this is drawing together lots of different reactions, lots of different mechanisms. And in each of those, you need to remember what the reagents are going to be. Sometimes you need to remember conditions. Let's take a look and see if we can work out which of these is not correct. Well, step 1 is elimination. And elimination is done in alcoholic KOH. It's ethanolic aqueous conditions. And so we would end up with the alkene there. If I move across to step 3, I'm going from a haloalkane to an OH. That's nucleophilic substitution. So in that, I'm using aqueous hydroxide ions. In this case, aqueous NaOH, that works. And if I go from an alcohol to an alkene, that is elimination. And concentrated sulfuric acid is a very good reducing agent. So that leaves us with B. Now, we've got the right mechanism. It's an electrophilic addition, but actually this would not be with Br2. To get to Y, you would do it with HBr. So the correct answer is B. Next question. You'll notice I've added the 3 here. There was an error when this went out on the question paper, but you're naming this compound. So the first step, you're identifying the longest carbon chain, and it isn't always as straightforward as you might think. I've got 1, 2, 3, 4, 5, 6 carbons in a row. That means that my correct answer is C or D. If I then number those carbons, I will end up with D. 3,4,5 trimethylhex-3-ene. And what I've done here is redrawn that in a different way so you can hopefully see that chain more effectively. And there is no harm in you resketching it in a form that you're more familiar with if it's going to help you to answer the question. Okay, next question. So which of these is not a suitable method for the preparation of ethanol? Well, direct hydration of ethene and hydrolysis of bromoethane we have learnt about in great detail this year. In terms of the reduction of ethanol, in year 13 you've learnt about this. There's a mechanism that goes with it, and it leaves A, oxidation of ethane. But you could potentially have got to that even if you did not know that C was correct, because there are very limited reactions that we know about alkanes. We can combust them and we can make haloalkanes. But if I'm thinking of oxidizing an alkane, adding oxygen, I'm thinking complete combustion, incomplete combustion. I am not thinking that I'm going to make an alcohol. So the correct answer is A.